Section is over solving linear systems by using the method of linear combinations. And so this is our third method of solving linear systems. The first step in linear combinations is to actually arrange the equations vertically. And when you do the equations, you want to have like terms in columns. So in other words, you want to have x's on top of x's, y's on top of y's, equals on top of equals, and numbers that are by themselves on top of other numbers that are by themselves there. Once you have everything aligned there, you need to manipulate one or both equations so that when you add the columns up, that one of them cancels out. And so an example of what you would do then is you'd want one to be like negative 5x and the other one to be positive 5x, because negative 5x plus 5x would cancel out. Once you have one of them to cancel out, then you go through and solve for the remaining variable, the other variable that's left. The nice thing is once you get to that point, you'll have something like x equals 3. Then you can substitute that into one of the original equations that you started with and figure out what the other one is. Remember that when you give your answer, to give it as an ordered pair. When you give it, if there's letters other than x and y, remember it is always in alphabetical order. So let's look at what this looks like here. The equations are there, and as you look at them, it's kind of nice. They're already lined up here. X on top of x, y on top of y, equals on equals, numbers that are by themselves on top of numbers that are by themselves. I like to get both variables on the same side, just like they have it there. What you're actually going to do in this method is you're going to add the columns. And so the reason this works here, the reason why I'm ready to go, is because these two are actually going to cancel out. Negative x plus x is going to equal 0x. So I'm done with my x's. Now 2y plus 6y, that's going to equal 8y. And then negative 8 plus negative 16, that is going to be negative 24. Now I solve for y quickly. Divide by 8, divide by 8. Y is equal to negative 3. Now once I know that y is negative 3, I can go back into either one of the originals. I'm going to pick this one because it's all positive there. So I'm going to go ahead. X plus 6y is equal to negative 16. I'm going to plug in the negative 3. And so 6 times negative 3 equals negative 16. Make sure you don't lose any of your negatives. 6 times negative 3 is negative 18. I add 18 to get rid of that. Add 18. X is equal to 2. And so as I look at that, my ordered pair is 2, negative 3. Now I could go back and check that solution with both of these and see if it's true. If you do go back and check it, you'll find that 2, negative 3 is the solution. Now the next problem here, look at this one. The temptation that a lot of students have is they try to go ahead and do it right away, but we can't do it there. Look at my columns. I have u on top of v. That's not going to work. I have the equals on top of equals, but none of the other stuff is on top of it. So I got to get them into columns. To do that, again, what I like to do is I like to get all of the variables onto one side. So I have the 2u already. I'm going to go ahead and subtract 4v. And I have 2u minus 4v equals 8. Now to get these on one side, I got to subtract 5u. So I have 3v minus 5u equals, so I subtracted this, so I still have negative 13. Now as I look at it though, I have u's on top of v's and v's on top of u's here. So I got to switch them around. Make sure when you do that, you take care of what the signs are. And so I have 2u in the first one, so I'm going to leave that first one the way it is. But the second one, I want this whole thing right here. So I look slightly to the left of the 5, that's negative 5u. I look slightly to the left of v, that's positive, so plus 3v, and that's equal to negative 13. Now I'm still not ready just to go through and add them and use the method of linear combinations, because nothing's going to cancel here. So somehow I got to get these to cancel. Now the bad thing is I don't necessarily want to multiply by decimals. So in order to get the 2 to cancel here with the 5, I'd have to multiply by 2.5. I don't necessarily want to multiply through by decimals. So what you can do though is you can go ahead and multiply everything here by 5 and then go through on this one and multiply everything by 2. Because when I do that, 5 times 2 is 10. 2 times negative 5 is negative 10. These are going to end up canceling out. But remember, when you do that, you have to multiply everything by whatever you're multiplying by. So I have to take the 5 and I have to bring it into both of them. That gives me 10u minus 20v equals 40. I go through here, I have negative 10u. Remember, that's the big one I'm looking at. That's why I chose to multiply by 2, is so I could get these to cancel out. But then I have to go through and I have to multiply this by 2 and I have to go through and multiply this by 2. Once I get the situation where they're going to cancel out, then I can add the columns. And so as I look at this, these cancel out, that's why I chose it. Negative 20 plus 6, that's negative 14. V. 40 minus 26, that gives me 14. Divide by negative 14. Divide by negative 14. V equals negative 1. Once I know that V equals negative 1, I can go through. Let me just get my eraser here. I can go through and I can substitute that into one of my originals. And so let's just say we know here that V is negative 1. So 3 times negative 1 is equal to 5u minus 13. So negative 3 is equal to 5u minus 13. Add 13. Add 13. I get 10 is equal to 5u. I divide by 5. I divide by 5. I now know that u is 2. Now remember, as we write this, we do need to write it in alphabetical order, and so in the alphabet it goes U and then V, and so I'm going to write this as 2, negative 1. And that is using linear combinations. So again, remember, first you have to manipulate the problem, and that may involve using addition and subtraction to get all the U's on top of U's, the V's on top of V's, equals on top of equals, that type of thing. Then you have to keep manipulating it to make sure that you get the situation where you have the positive number by the variable here and the negative same number by the variable here. That way they cancel out. Once you get to the point where one of the variables will cancel out, then you can go through and solve for a variable. Once you have one variable, plug it into one of the original ones over here, and that will give you the next one. And that is the method of linear combinations. Now, linear combinations is just the third method. It is a great method when things work out there. And so, again, we'll want to get good at working with this third method. Let me leave you with this little joke that I've heard before. How do you catch a unique rabbit? Will you sneak up on him? How do you catch a tame rabbit? The tame way. Remember, kids, as Christmas approaches, ask for the gift that keeps on giving, and the gift that keeps on giving? Bacon. Have a great night.